Hello and welcome to Chapter 6. Today we are covering static routing. So what we're going to do today is we're going to go over static routing and how to configure static routing. We'll also learn a little bit about how to summarize route to reduce the entries in the routing table. So we'll take a look at that as well. By the way, we'll see also how to create a static route in IPv4 and IPv6, a review of subnetting. I think we're going to skip that because we'll be doing that in class and we did that already. So for those who are not, I mean, I'll just go through the slides really quick. I don't think I'm going to cover that. So because we've been doing that so many times and we'll review that in class again. Okay, and then we'll take it from there. So hopefully it'll be a pretty easy chapter, I think. Only a couple of commands that you have to really remember, and you'll see how easy it is. Okay, what is a static route? A static route is an entry that the administrator will go in and type into the router. It'll tell the router which path the package needs to go to if they've been sent a packet. In other words, if let's say you are in New Jersey and you get a packet that is going to go to somewhere to California. So what we need to do is I'm going to tell the packet in New Jersey, if you ever receive a packet with the destination IP address to West, let's say San Francisco, please send it to Pittsburgh. Okay, so you type that in. Why do you want to do that? Because the router is only, we'll talk about that. Why do you want to type in the route yourself to tell the router what to do? Dynamically means the administrator doesn't really get involved. The routers themselves communicate with other routers, neighboring routers that are connected to them, and they pass updates to each other, and then the routers will build their own routes in the routing table. Um, we'll be covering dynamic routing later on this semester, but tonight we are going over manual static routing. How do you enter routes into the routing table? So why do you want to use static route? Why do you want why is it sometimes important? Well, I don't know if it's important or not. What are the advantages, as this slide says? What are the advantages of doing static routing over dynamic routing? Well, for one reason, if you have an old router, for example, an old router doesn't have a lot of CPU power, doesn't have a lot of memory, you type in the static route and then the router doesn't even have to think anymore. It knows exactly which path it's going to take, right? That's number one. Number two, if you have the only way out, let's say a lot of networks, for example, on our campus, our router is connected to the ISP. And since we are only connected to the ISP to the outside world and no one else connect to us, we are called a stub network, STUB, right? A stub network means you have no one else to communicate with in the outside world except one direct connection. As an example, as the ISP. So why run dynamic routing when your packets are only going to go to the ISP? So therefore, you type a static route to say to the router, if you receive a packet, send it to the ISP. So therefore, the router doesn't use a lot of resources in calculating and trying to figure out a route. And it's not being advertised, as we will discuss when we are discussing dynamic routing. Dynamic routing meaning routers talk to each other and they advertise the networks that they have. Statics route are not advertised and therefore it's more secured because no one else sees them. They're not advertised and they consume less bandwidth, right? The disadvantages of static routing, one big one is if you have a large network and there are multiple paths to the destination and you want to pick the best path. Best means the quickest way, the quickest way. So it becomes a little bit of a headache for the administrator trying to find the best path and to type that in. And then not only that, he has to keep track. The administrator has to keep track of all the static routes that he did, and then and if a path fails, the administrator has to get involved and then retype in the static route. Let me give you an example. Let's say you are on campus and your mama told you to take a certain path to get home. Now, why did your mother tell you to take a certain path to get home? Well, maybe because she doesn't want you to think for whatever reason. So you want you to, as soon as you're done with your classes, back up your books and head on away. Because number one, she knows the path that you're going to go to get home, and you don't even have to use your GPS or anything. You will take the path that your mama says, right? And if anything goes wrong, it knows the path that you took, and she can come and pick you up. The disadvantage is that she has to pick you up. You're not rerouted. You have to call her, and then she has to reroute you, tell you, okay, now you got to take another path. Now, that's static routing. Now, if there's only one way to get home, might as well tell you that, and so you don't even have to think when you leave school, right? Now, dynamic routing means as soon as you're finished with school, you type in your address that you want to go to on your GPS, and they will calculate the best route to the destination. And if there's a problem on the way home, they'll reroute you. All right? There's a detour, and eventually you'll get home. And you're always using the best route to the destination. But you may go through, bad neighborhoods, right? Unsecured. You may think of it that way. This is just an analogy, obviously, right? So dynamic routing is a lot more useful when you have a very large network, a lot of routers around, and there are multiple paths to get to the destination. Okay, the primary reasons why you want to use static routing. You reduce the entries in the routing table because less entries, that means the router has less paths to look up, right? And if you have a stub network, like I said, you know, if your only way out is to the next hop, so there is no other reason but to use a static route. I mean, why bother not do, why bother run dynamic routing? And also you use a static route. If let's say a packet comes into the router and I look up all the entries in the routing table and none of the entries in the routing table matches the packet where the destination is going. What are you going to do with the packet? If there is no default static route typed in the router, those packets will be thrown out in the trash. So we need to use as default static route to make sure that the packets that do not match any of the entries in the routing table, they are rerouted somewhere else. Excuse me. All right, that's called the gateway of last resort when we do that, and we'll see that in a few minutes. Okay. So here's a stub network. So for example, here's our LAN, and the only way out is to get to here, right? So this is called a stub router. This is a stub network. So what you do is you type in a static route and you tell this router R1, if any packet comes into you, send it out to R2, right? This might be your service provider. All right, and the static route is with quad zeros, which we will see in a few minutes. Okay, and also a static route allows us to summarize a whole bunch of different routes. For example, on R1, I can represent all four networks with one network. So why, for example, telling R1 if a packet comes in going to 172.16.0/16, send it out of here. 172.21, send it out of here. 172.22, send it out of here. Why have four entries in the routing table going out to here, right? All these networks right here going out of the same interface. Wouldn't it be, I mean, you have four entries in the routing. Wouldn't it be nice if we can summarize all of these into one route and put that one route so you have, you know, uh, only one entry in the routing table instead of four entries because they are all going out of the same interface. I'll give you an example. I live in New Jersey, right? And if a packet comes in and it's going to Pittsburgh, it's going to go on the west interface. If it's going to St. Louis, it's on the west interface. If it's going to Denver, it's going on the west interface. If it's going to San Francisco, it's going to go out of the west interface. Can't we find something, similar between San Francisco, Denver, St. Louis, and Pittsburgh, and we combine them and and just because they are going out of the same interface, maybe we'll use the word west. If the packet is going west, just send it out of the west interface. That summarizes the route immediately instead of having four entries in the routing table, we'll just have one. We'll see an example on how to calculate a summary route and later on, okay? But for now, static route allows you to do that to minimize the number of entries in the routing table. Floating static route. Floating static route means a backup, really. If let's say, for example, you want to use this route all the time, but if this fails, you want a backup just in case. So you can type that in and say, well, remember the administrative distance? That gives you the reliability of the how reliable the route is. So let's say you're using EIGRP and it has an administrative of 90, and your router picked up a route using EIGRP, and it will always go that way. So you want to say, all right, if that route fails for whatever reason, I want to take a different route. So what you do is you type a static route going to the same destination, and at the end, as you will see in a few minutes, you type in a number greater than 90. Once you type that in, that static route is called a floating route, which means it will stay in the routing table and we will always use the EIGRP because it has 90. And the floating, well, the backup static route will have something, let's say, 100 as the administrative distance. If that EIGRP route fails, immediately the floating static route will be used. All right? And we'll see also an example of that later on. Okay, so the command that you use is you type IP route and you type in the destination IP address with the subnet mask, and then you either type the next hop address or your exit interface, which we'll see in a few minutes as an example. Okay, so there are two ways of writing the static routes. You know what? We can actually do that right here. Let me give you an example. Let's go to Packet Tracer and just throw that in there. Makes it a little bit easier. So let me take in a 2811 router, take in another 2811 router. Okay, let's call this, leave it as R0. Okay, we're gonna have to put in the a serial port. So open up the packet tracer in the back of it, turn off the router, go ahead and pick up a WIC2T from down here and put it right in this slot right here. Okay, then turn the router back on. Close that. Open up the second router. Turn off the router. And pick up a WIC2T. And put it right here and turn the router back on. All right, let them boot up. Let's pick up two PCs. One right here and one right there. And let's connect the PCs with a crossover cable to the fast Ethernet 00. And let's connect this one with here with the fast Ethernet 00 as well. Let's get a DCE, the line with this one right here with the clock. Go over R0, use the serial 000. Go to R1, use serial 000. Okay. All right. Here are the networks that I'm going to type them in. This network right here is going to be 192.168.10.0/24. This one right here, let's make 172.16.100.4/30. And this network right here, let's make it 10, 20, 30, 128 slash 64, right? Let's put in the IP addresses for the PCs. Click on the arrow right here. Let's go to PC1. We got to do the basic configuration first. Remember, question number 1 is you have to put this in your homework, okay? So don't forget, when you're finished with this, we have to submit that as homework for chapter 6. Okay, go to the desktop and type in the IP address. The first IP address goes to the PC, which is 192.168.10.1. It's a /24, so, oops, let's type in the address, 192.168.10.1. /24. The default gateway is 192.168.10.254. Right? Okay, let's go to this PC. And the PC in the other LAN right here, this guy. Let's give him the IP address, which is 10, 20, 30. And the first address is 129. Okay, it's a slash. What the hell is a /64? There's no such thing as /64. What am I talking about? It's /26. Sorry about that, guys. I must have confused the hell out of you then. All right, /26 255.255.192 at the end, right? And the default gateway is 10, 20, 30 dot. Okay. Does anybody know what the last IP address would be? I'll give you a second to think about it. Okay. What's 255 minus 192? 64, right? So it's that, let's say, 190, right? Okay. So dot 190. Let's go right here. Assign the IP address. Go to CLI. Say no. Let's just type in the IP addresses. Type en config t host name. Let's call it R0 and no IP domain lookup. Let's go to interface fast Ethernet 0/0. Give it the IP add 192.168.10.254. Right? Subnet mask 255, 255, 255.0. And let's open it up by typing no shut. Okay, let's go to this interface right here, the serial 000, INT serial 000. Let's give it the IP add, which is just the first address, 192.160. Oh, no. What the hell is 192? 172.16.100.5. Right? So that this one is .5. Subnet mask 255, 255, 255, 252. That's a /30, right? Now, because it's a DCE, remember we picked the clock one and we put it right here first. So we have to put a clock rate on this guy. Clock rate of 64,000. And then you say no shut. Okay? Now, remember, it's still red because this interface is not active yet. So let's go to R1. And, oh God. Let me bring this back up. Okay, let's go to R1. And let's go to the fast Ethernet 0/0 interface. say no, type en, config t, host name R1, no IP domain. Look up, right? Let's go to interface fast Ethernet 0/0. Give it the IP address of 10, 20, 30, 190 with 255, 255, 255, 192. That's a /26. No shot. Now let's go to the serial 000 interface. Serial 0/0/0 and give it the IP ad 172.16.100.6. Right? So this guy is going to be .6, this guy is .5 because it's a link, right? /30 is 255.255.255.252. And you type no shot. And now everybody is active, right? Now let's go right here. And what we're going to do is click inside and just do Control Z, get out, and type show IP route. You see there are two entries in the routing table. C's means directly connected. This network and this network right here. So PC1 cannot ping, PC0 cannot ping PC1. Why? Because, well, let's try it. Well, let's ping the default gateway first. Let's ping his default gateway. So I go to PC0, go to command prompt and type ping 192.168.10.254. And now ping in my default gateway. That's good. Let's try to ping PC1. Well, if I type ping 10, 20, 30, 129, and I hit enter, it says reply from my default gateway, which is 192.168.10.24. Destination host is unreachable. When you get this command, destination host unreachable, after you ping, that means your router doesn't know how to reach the network that you're trying to do. So what we're going to do is we're going to type a static route. Let's go in and type a static route. You type in a static route at R0 by go to config T, and you're going to say config T, and you're going to say IP route. So you're telling the router, if anybody wants to go to this network, 10, 20, 30, with 128, you have to type in the network address here, not PC1 address, the network. And a subnet mask 255, 255, 255, 192, which is the destination subnet mask. So you're writing, if anybody wants to go to this network with this subnet mask, remember this is the destination, please send them out of this interface right here. This is the exit interface. So that interface is serial 0/0/0. 10, 20, 255, 255. I typed something wrong. IP route. Oh, I didn't put a dot here. Look at that. So right here, there should be dots, right? Good. I don't even have my glasses on. All right. So here is your route. Now, you can either type in your exit interface or the next hop address. So you could have wrote this the same way, but instead of writing serial 000, you could write 172.16.100.6. You cannot write the IP address of your exit interface. If you want to use the exit interface to leave, then you got to use the name of your interface, serial 000, not the IP address. If you want to use an IP address here at the end, it has to be the next hop. Okay, we'll do an example later on. All right, so let's check out the routing table to make sure that it has been inserted in there. Type exit and type show IP route. And there it is. You see the letter C. If anybody wants to reach 10.20.30.128 network, go to serial 000. All right, good. So now let's try PC0, see if he can ping PC1. So I hit the upper arrow key to repeat the command. And let's see what happens. Uh-oh, still doesn't work. Can anybody, do you know what happened? Timing out. Different error, right? This one says destination unreachable, but now it's timing out. I'll tell you what happened. This guy knew. Well, he looked up the routing table. He says, oh, you have to go here. So he sends the packet here, and the packet reaches this guy. And he says, oh, I know where you want to go. You want to go to this guy. So he sends him that ping command, the echo request. So he creates an echo reply, sends it back to the router, and then router one says, oh, I don't know where to go with this packet that you're sending me. The packet, the TTL number that is stamped on that packet keeps decrementing while the packet is sitting here. And then remember the ICMP sends you say, hey, packet has died. That's why you get this timed out. So what do we need to do? We need to go to router 1 and write a static route that reaches this network, right? So I'll go to router 1 and I'm going to do exit right here to make sure I'm at the config mode. And I'm going to type in the command. Remember, I'm on router 1. IP route space, if anybody wants to reach, it's better to say it, by the way, 192.168.10.0 with subnet mask 255.255.255.0. Go to, you know what, let's, instead of writing the exit interface, let's write the next hop address this time. So it'll be what? 172.16.100.5, because that's this interface right here, right? That's it. Okay, let's type exit. Verify the static route is in the routing table by typing show IP route. And there it is, right? Excellent. Now let's try the pinging again. So I go in, I hit the upper arrow key, and I hit enter, and they all reply to each other, and everybody's happy, right? So now they got routes between them. That's what a static route is. Now you see, static route, it's nice because I have a stub network. I type it to you, and this guy has a stub network, and he writes in a static route, and now they communicate with each other. There is no reason to run routing protocol. It's very quick, and it's nice and easy. Now, the only thing is what happens if a packet comes in and it does, I go here, here, here. What do? You have to type in a default route. See, the gateway of last resort is not set, which means if a packet comes in and I go and look at every single packet and it doesn't match, the packet is going to go in the trash. So if you try to ping someone else, anything else, it's going to fail and the packet gets dropped. So this is how you type in a static, what do you call it? A default static route. Go to config T. Just want to show you something. Just for an example. You type IP route, and it's a quad 0, space, 0, no, 0.0.0.0 space, and let's use the exit interface, 0/0. Now I want to use this, I know it doesn't make any sense. You're going to bring everybody out of here anyway, so there is no reason to type the other static route. But what this means is the following, and you know what, this is the default route, which means this is the gateway of last resort. If nobody matches, you're going to be sent to serial 000 anyway. So let's see how that looks in the routing table. Type exit and type show IP route. And see the S with the star? That's your default static route, which means if I check every single packet and nothing matches, you are going to go to serial 000. So the gate is last resort set to this network. And why is it a default? Because look, if you give me any packet, any IP address, the destination IP address, and I end it with this subnet mask /0, what's the result? End it with 32 zeros. You're going to match. You're guaranteed to match. That's what that static route does. And once you match, then you are sent to serial 000. That's what that static route means. All right. Make sure you save this, and that's going to be part of your homework. In addition to some questions I will ask you later on. All right. Let's go back to the slides, and we're right here. All right. So we either can write the next hop address as I've shown you. Static route only exit using the exit interface, and fully specified static route is the next hop address and the exit interface. They are shown in the routing table. You can have both of them if you want to. All right, so as we have seen, this is the directly connected route. If you have 3 routes, this guy has to write a static route to reach here, then go here, write another static route to reach if you want to ping PC3. Right, so you have to type a static route here and a static route, then go to router 2, tell them, hey, if you get a packet destined to this network 192.168.20, send it here. And then go to this router. If you want to reach 172.16.0, send it to R2, and then go to R2 and send it here. So if you have 3 router connection, that's only to reach here to here, and never mind PC2, you have to type 1, 2, 3, 4 static routes. 4 static routes. All right, and if this guy wants to reach this guy, there's one more static route here and one more static route here to reach PC2. So 6 static routes right here if you only have one network attached to these 3 routers. Now look, 3 routers with 3 networks, and you need to type in 6 static routes. Anything beyond that is probably a good idea to use dynamic routing, right? So here are the commands. This is using the exit interface. So if you go to R1 right here, you type in, if you want to reach 172.16.10, go to serial 000, your exit interface, right? If you want to go to 192.168.10, which is this interface, go to serial 000. I don't know why you want to reach a link for, but that's another network. And if you want to reach 168.20, which is this network, you still go to the same exit interface. So 3 static routes, and there they are, 3 static routes, right? Here, now, to verify the static route, you can either type show IP route or show IP route static, specifically for the static, not everything in the routing table, like show IP route, or show IP route the network that you're trying to reach. Okay, here's the default route. You can either use the exit interface or the next hop address. Right, we did that in the configuration. So you can type IP quad 0 space quad zeros. This time they're using the next hop address instead. Right? Verify it by typing show IP route static. Here we go. It shows that this route a static route, and it comes up right here. Just the static route shows up. IPv6 is pretty much the same thing as IPv4. There is really not much difference. You just write really the word IPv6 route, and then you type in the destination network address with the slash, and either you type in the next hop or the exit interface. Pretty much the same thing. There's no difference between v4 and v6 except the IP addresses. You type IPv6 route. Here's the destination. 2.0 network, right? That's this network right here. And you should go to the next hop address .2, which is this guy right here, right? If you want to go to the 5 subnet 0, which is this network right here, go to .2. You want to go to the 3.0 subnet, which is this network right here. You still go to .2, right? This guy right here, remember, that's your next hop, even though you're trying to reach this network. So it's pretty much the same thing for IPv6, right? And same thing right here. If you want to use the exit interface, it's pretty much the same thing, but now you're using your serial 000 instead of the next hop address. Okay, fully specified static IPv6 route. So you can actually type in that in and type in here is the, and it will show up something like this. That's what I mean. You can have your exit interface and your next hop address shown in your routing table. How do you verify IPv6 static routes? You can type show IPv6 route or IPv6 static routes. Okay, so here is the default static route, IPv6 route quad zeros, and this is the destination, next hop address, right? All right, question number 1. I want you to write a static route for IPv4. I'm not even going to tell you the answer this time. Just give me any example, right? Using an exit interface, using a next hop address, and do the same thing for IPv6. Do a static route, and just make up any destination network address, make up any static next hop address, make up any, I just want to see the command. You can make up the next exit interface. So IPv4 and IPv6 static routes and default routes. That's the question. Make sure you write that um, in a Microsoft Word. And also, question number 2, I want you to write me a static route. The same, well, not actually, question number 2. For the same thing, I want you to give me the floating static route. Remember, you type in the same IP address, and at the end, you write a number high, just write a number, an administrative distance, the backup routes. If you don't remember what a floating static route, look at it towards the end. You'll see what I'm talking about. Review. Go back on these slides, and we talked about that earlier. All right, here we are talking about subnetting, classful and classless. So what I'm going to do is I'm just going to really go over this very. I'm just going to go over these slides because there is no reason to go over it because we're going to be doing this extensively in class, as you probably already know. So we're doing VLSM constantly. We've been subnetting, and hopefully everybody knows how to subnet by now. If not, you need to come and talk to me. All right, route summarization. So this is a time we are going to summarize a specific route. Let's say you have a network, right? So let's say you have 172, 20, 21, 22, and 23. They're all exiting the same interface. So what you need to do is you need to find something similar out of these 4 networks. So what you do is you know that 172 is the same, so you leave that alone. Here's where they differ. The 20, 21, 22, and 22. So you break 20, 21, 22, and 23 all in binary right here. And you go count the bits, which are the same. The first bit is okay, second, okay, third, okay, fourth, okay, 5 and 6 are okay. It's on the 7th bit where they differ, right? So the first 16, sorry, first 8, 9, 10, 11, 12, 13, 14 bits. The first 14 bits are good, right? They're all the same. So what you do is you write the first 14 bits, which is 172 dot. And what's this number right here? Assuming everything else is zeros after that, it is what? This is 16 plus 4, right? 20. So 172 dot 20, and then you write zeros everything after that. So 172 20.0.0 slash 14. That will be the summary route for all of these. Okay? So question number 2, what does a summary route do? Why is it preferable to summarize a route? A summary route is used to reduce the entries in the routing table. And what you do is you summarize, you find the bits that are the same, and you write one entry in the routing table instead of multiple entries because they are exiting the same interface. I mean, you don't have to write all that answer as long as you can briefly explain what I just said. So instead of having 3 entries in the routing table, you'll just put this one entry with a slash 22 instead. So here's another example. Right, the first 16 and all these zeros all the way up to here are the same. So take a look at these past 2 examples on how to create static route. We'll do that when we go over EIGRP. All right, how do you summarize IPv6? Pretty much the same thing as you would do with IPv4. And here are the steps. You can use these steps, by the way, 1 to 7, when you are summarizing IPv4 as well, right? Maybe we'll do it. We'll do an example of that in class too. Okay. So here is a summary. Here are multiple 4 different networks going out of the same interface. You can actually type in slash 45. You know, if you look at all of these 4 networks right here, so you can go to R1 and tell them, listen, if anybody go in with the first 45 bits looking like this, send them out to the .2 interface. And then when the packet reaches here, this router knows out of the 4, right? You don't have to summarize here. This guy should have a summary. So this guy has only 1 entry instead of having 4 entries in the routing table, right? So summary is nice. All right, here's the floating static route that I talked about earlier and asked you a question on it, right? This is the backup for dynamic or static routes. So if you have and here is the example. There we go. So here's your answer actually for that question. So you're saying to this router 1, if anybody wants to go to the default route, it should be sent to 172.2, which is in this to this interface, the exit interface, right? I'm sorry, not the exit interface, the next hop address. And what this one does, it's pretty much the same thing, but you having a different, right? Another default route to a different next hop address, but then you write an administrative distance number 5. Why is this one going to be used first? The 172.16.2.2 next hop? Because it has by default, the default administrative distance for a static route, if you remember, is 1. Because this one has an administrative distance of 5, this one will not be used. Unless this one, the one with the primary one fails, then this router will use the 10.10.10.2 next hop. Right? It'll be a backup. That's what a floating static route is. Right? How do you test a floating static route? Type show IP route, verify in the routing table that you have the original one. You can type trace route, make sure the primary one is being used, right? So you always use that. Make sure that this is not connected. And then what you need, you can use any of these commands to troubleshoot. You can use the ping, the show IP route, show IP interface brief. By the way, it's a good idea to use these commands and look at the output and see what it's giving you so you'll know what you need them for, right? And so you can ping 170. By the way, these commands, some of these commands you cannot use in packet tracer, like for example, this command. I never tried, but I don't think it works on packet tracer. You have to be on the physical routers to really try some of these commands. Okay, and you can go and try it if you want. If you have access to the physical router, you can do that. And that's it for chapter 6. So please answer those 2 or 3 questions that I asked you on a Microsoft Word and submit that packet tracer example for static routing. This one right here. And then we are all good. All right. Until we meet again in chapter 7. And God bless.